So next, let's take a look at the full-length 16S microbial identification, which is one of the most common method for rapid and cost-effective microbial identifications. So the 16S genes has 9 hypervariable region. I believe many of us know level SV1 through V9, which are positioned between the conserved sequences. So these variable regions can is very useful because they can serve as the species specific signatures. So it makes them very valuable for the bacterial identifications and classification in the microbial community profiling. And V3 and V4, these two regions are very commonly used for general bacterial profiling because they offer a good balance between the resolutions as well as the coverage. And for V1, V2, or the rest of the hypervariable regions, they tend to be more variable, but it may offer a better discrimination for certain bacterial groups. So if we compare traditional sequencing methods such as Sanger sequencing and short read sequencing, typically they targets only a few hypervariable regions, for example, V3 and V4. So this may limit the amount of sequence information available and reduce the resolutions for the species level identifications. So in contrast with long reads, such as like Oxford Nanopore, we allows the full-length 16S sequencing. We cover the entire 9 hypervariable region. So this approach will provides a higher taxonomic resolutions, and it allows more accurate species level identification, particularly for closely related organisms. So we in Nanopore we do have 16S barcoding kit available, readily available. So you can, if you want to multiplex samples, like for example, to reduce the price of sample, if you only want to do 16S sequencing and you are interested in genus level bacterial identifications, and why we say genus level bacterial identification is that sometimes even with the full-length 16S sequencing, it can be insufficient for species level identification because a certain bacterial species share a very similar or nearly identical 16S gene sequences. So this can make it, make it very difficult to distinguish between these very closely related species. So in this case, the whole genome sequencing or sequencing of additional genetic region, like for example the ITS regions, will be very helpful for a more precise species level identifications. But however, if you want to do 16S sequencing, we have these available. So here you can see the overview information of this 16S barcoding kit. So this kit helps to amplify the entire 16S region, 1,500 base pair approximately, followed by the library preparations where the DNA is amplified using a specific 16S primer. And then the kit has a preparation time of 25 minutes plus PCR. And it also requires 10 nanogram of genomic DNA per sample. It uses the kit 14 chemistry, which is our latest chemistry. It also includes 24 unique barcodes. It allows up to 24 samples to be pulled in one sequencing run. And in the post-sequencing, the analysis can also be performed using epitomy, and there is a WF 16S workflow that you can use. So you can see that this is a very, very simple end-to-end workflow with extremely short hands-on time. So the analysis workflow, as I mentioned, the name is WF16S. This is again freely accessible. Can be used to analyze 16S. However, it can also be used to analyze 18S or ITS region if those have been included in your sequencing. So all the epitomy workflow are available in both graphical user interface or command line. You can run it locally in your own device. You can also use cloud. And there will be also a similar software looks, no matter is locally or analyze it in cloud so that there's no confusions and it's, user friendly for you. And with nanopore sequencing, one of the very powerful feature that we have is that real-time analysis is possible. What this means is that it allows the workflow to run continuously as the sequencing data is generated, which means that you can actually visualize the classification of the reads and the abundance of species in real time, dynamically updating reports. So you can know that, actually I already have sufficient data. I can stop the sequencing run. I can preserve it for the next run. And of course, if you want to analyze the data at the end of the sequencing, wait for the whole sequencing to complete, you can as well. And our analysis workflow provides very intuitive reports with interactive graphic as well. So, it's easier for you to visualize the data. So here's a case study um, showcasing the nanopore 16S sequencing using our lattice chemistry. So this has enabled a highly accurate full-length 16S sequencing for environmental microbiota profiling. So in this study, the author has used the lattice chemistry and achieved 99% of raw rate accuracy. And also it demonstrates that here, both Nanopore and an alternative long read platform provide a very similar microbial profile, while the short read has a limited resolution for species level identifications. And they also find, and emphasize that the nanopore sequencing has enabled a species level taxonomic identification from the environmental sample, highlighting its accuracy and its applicability of microbial community analysis. And also, I think it's important to keep in mind that nanopore sequencing has continued to improve its sequencing accuracy, and also nanopore sequencing um, platform offers you a very cost-effective solutions, not only in terms of the sequencing instruments, but also with a lower running cost compared to other platforms. And it's also very highly flexible. You don't need to batch your sample if you don't need to, and therefore you have a faster turnaround time. And this is very critical, especially in clinical settings, because you cannot predict how many samples is coming in for today, and you need that sample as quickly as possible. And because of our ability to generate real-time analysis data, it is also very powerful because you can fully, utilize the flow cell um, just to the point that you generate sufficient data for your analysis.